Okay, this is section 1.7 from the Stewart book on parametric equations. What you're used to graphing most likely is y as a function of x. Even your calculator's default mode is function mode, where you put in a y1 equals, maybe a y2 equals, a y3 equals, and so on. In that case, you are writing y as a function of x. You can also write x as a function of y. So, for instance, y equals x squared would be a parabola. X equals y squared would be what you would probably think of as a sideways parabola. And to graph that on your calculator, you would put in a y1 equals the square root of x, and a y2 equals the negative square root of x. But that's when you can take an equation that has x and y in it, and you can actually solve for y. That's when you can graph something as a function. But suppose you want to graph an equation that you can't write explicitly as one variable in terms of another. In that case, you're going to need parametric equations. How that works is you find a different variable, or you use a different variable. In this case, we're usually going to use the variable t, and that's going to be called your parameter. You will define x in terms of t, so you will write x as some function of t, and you will write y as some other function of t. That's what a parametric equation is, and that's what gives you something that looks like the graph that was shown on the previous page, which you can rewind if you would like to see again. One thing that might help, of course, because he always helps with everything, is Khan. So you can check out this link, or you can just Google Khan Academy Parametric Equations, and this will come up, and he'll give you some examples. And I'm also going to do some from your book on the next 2 pages. So these are the directions for 1 through 4. You are to sketch the curve by using parametric equations, these parametric equations, to plot points. And then we're going to use an arrow to show the direction in which the curve is traced. The way parametric equations also work is you are given some range, let's call it, or some interval for t. So in this case, t is going to be between 0 and 5, including 0 and 5. In this case, t is going to be between 0 and 2 pi, and so on. So when you make your table of values, which we'll do on the next page, like an x and a y is what you're used to, we're also going to have this first column with t. We'll put in different numbers for t out of this interval, the given interval for the function. Then we'll figure out the resulting x values, the resulting y values, and the x, y ordered pairs are all that we're going to actually plot. So again, with something that might be helpful, you're going to have a table of values for any of these, where you're going to use for your t values something in the interval that they give you. You're going to plug those in for your x function to get your x's out, and you're going to plug it in for your y function to get your y values out. Then you're going to plot all your ordered pairs, and then we're going to put in, you'll connect them, and then you'll put an arrow on your curve indicating which way the path traced.